In this video, let me consider one example on basic operation of signals. Given the signal x of n, 8 minus n multiplied with u of n minus u of n minus 7, sketch the following signals. Y of n is equal to x of 4 minus n and g of n is x of minus 2n plus 3. So here the signal x of n is given. With the help of x of n, we are supposed to sketch y of n signal and g of n signal. First, let me take the x of n signal. So x of n is equal to 8 minus n, u of n minus u of n minus 7. Let me draw x of n signal. So here we have u of n minus u of n minus 7. This will give the range of the signal from where to where the signal exists. Let me draw this so that we can understand better. So let me draw u of n signal here. We know that u of n exists only for n greater than or equal to 0. Say this is 0, 1, 2, 3, 4 and so on. This is unit step signal whose amplitude is 1 and so on. So this is u of n. So let me draw u of n minus 7. U of n minus 7 is again a unit step signal which begins at n equal to 7. That is shifted unit step signal. So here it is. So say this is 6 and say this is 7. So let me consider u of n minus 7. So when we think of u of n minus 7, it begins at n equal to 7. So this is 7, 8, 9 and so on. Here the signal begins. So for n less than 7, the value is 0. So this will be continued till infinity. This is n axis. If you perform u of n minus u of n minus 6, so the resultant signal will be like this. That is, so u of n minus u of n minus 7 up to 6, 1 minus 0 is 1. So the same signal will appear, that is 0 to 6 samples will appear here. That is 0, 1, 2, 3, 4, 5 and 6. So 0 to 6 samples will appear as it is. So at 7, here the magnitude is 1, here also 1, these two will get cancelled. So 7 onwards, all the signals will get cancelled, we'll get only this signal. So this is u of n minus u of n minus 7. Now let's see what is 8 minus n. So here let me draw 8 minus n. Now we can say that x of n exists only for 0 to 6. So now let me draw x of n signal. Say x of n, let this is n equal to 0, 1, 2, 3, 4, 5 and 6. So x of n exists only for n equal to 0 to 6. So if we consider n equal to 0, so x of 0, that is for n equal to 0, x of 0 will be equal to 8. So at n equal to 0, the magnitude of the signal is 8. Let its value is 8. Now for n is equal to 1, x of 1 will be, that is we substitute n equal to 1. So 8 minus 1 is 7. At n equal to 1, the value is 7. Let this be 7. Similarly for n is equal to 2, x of 2 will be 6. So let this be 6. At n equal to 3, we have x of 3 is equal to 8 minus 3 is 5. So at 3 the value is say 5. At n equal to 4, we have x of 4 which is equal to 4. Say this is 4. And at n equal to 5, we have x of 5 which is 8 minus 5 is 3. So say this is 3. Now for n equal to 6, we have x of 6 which is equal to 2. So let this be 2. So this is the x of n signal. Now with the help of x of n signal, we have to perform the next operation. Here the thing is, we are supposed to sketch y of n signal, where y of n is equal to x of 4 minus n. So let me consider y of n signal now. So y of n is equal to x of, we have 4 minus n. So here y of n signal can be drawn in, here y of n signal can be computed in two ways. Let me solve the first method. So here I will consider the different values of n, that is, for n equal to 0, we have y of 0 is equal to x of, if we substitute 0 here, we will get x of 4. So value of x of 4 is, here we can see the value of x of 4 is 4. Therefore it is 4. Now for n is equal to 1, we have y of 1 is equal to, that is n is equal to 1, we'll get x of 4 minus 1 is 3. So x of 3 will be, here we can see x of 3 is 5. Let me write 5 here. Similarly, for n is equal to 2, we have y of 2 is equal to 4 minus 2 is 2, that is x of 2. So x of 2 here is, x of 2 is 6. So this is 6. Similarly, for n is equal to 3, we have y of 3 is equal to x of 4 minus 3 is 1, that is x of 1. So x of 1 is nothing but 7. So therefore I can write it as 7. Now for n is equal to 4, 4 minus 4 is 0, that is y of 4 is equal to x of 0. So here we can see x of 0 is 8. So let me write it is 8. Now for n is equal to 5, we have y of 5 is equal to x of minus 1. So here we can see x of minus 1 is 0. So it is equal to 0. Therefore, now we'll consider n equal to minus 1. That is, n is equal to minus 1. In that case, y of minus 1 will be equal to, here minus 1 is x of 4 plus 1. That is x of 5. So x of 5 value is, here it is 3. So it is 3. Now consider n equal to minus 2. In that case, it will be x of 6. That is y of minus 2 is equal to x of 6. So x of 6, here we can see it is 2. It will be 2. Similarly, for n is equal to minus 3, we will get y of 7, where the value of, sorry, it is y of minus 3 is x of 7, it is 0. So minus 3 onwards, all the values will be 0. Now let me draw y of n signal. So this is y of n. We have 0, 1, 2, 3, 4, 5, 6 and so on. Say here minus 1, minus 2, minus 3 and so on. So y of 0 is 4. So at 0, the amplitude is 4. At 1, it is 5. Say it is 5. At 2, it is 6. At 3, it is 7. At 4, it is 8. So at 5, its value is 0. So this value is 0 here. Here onwards, all the values are 0. At n equal to minus 1, the value is 3. Say this is 3. At n equal to minus 2, it is 2. It is 2. Here onwards, all the values will be 0. So this is the y of n signal. So g of n is equal to x of minus 2n plus 3. So here also we'll follow the same method, that is for n equal to 0, g of 0 is equal to, we have substitute n equal to 0, we'll get x of 3. The value of x of 3 will be, here we can see x of 3 value is 5. So write 5 here. Similarly, for n is equal to 1, we have g of 1 is equal to, so if we substitute 1, minus 2 plus 3, that is x of 1. So the x of 1 value is, here it is 7. I can write 7 here. Now for n equal to 2, we have g of 2. So g of 2, minus 2 into 2, minus 4, that is minus 4 plus 1 is x of minus 1. So x of minus 1 value is 0. So here onwards all the values will be 0. Now we'll take n equal to minus 1. Consider n equal to minus 1. So g of minus 1 is equal to, substitute n equal to minus 1, that is 2 plus 3, x of 5. So x of 5 will be, here we can see it is 3. It is 3. Now consider n equal to minus 2. In that case, it will be 4 plus 3, 7. G of minus 2 is equal to x of 7, which is equal to again 0. So here onwards all the values will be 0. Now let me draw the g of n signal. So let this be g of n signal. So this is n axis, n is equal to 0, 1, 2, 3, 4 and so on, minus 1, minus 2, minus 3 and so on. At 0 we have 5, say this is 5. At g of 1 value is 7, say this is 7. At g of 2 value is 0, it is 0. At g of minus 1 value is 3, say this is 3. At n equal to minus 2 the value is 0. So this is g of n signal. Let me solve this problem using alternate method. Here the given function is, first function is, we have y of n is equal to x of 4 minus n. So I can represent x of 4 minus n as x of minus n plus 4, or I can write it as x of minus n minus of minus 4. It means that, so y of n is x of minus n minus 4. It means that the signal is begins at n equal to minus 4. So to perform this operation, first we have to do the shifting operation, then we have to apply reflection operation. That is, it involves two operations. One is shifting, second one is reflection. So first let me draw the shifting function, that is, here the x of, it will be x of n minus of minus 4. It means that the signal x of n is shifted towards left by 4 unit. It means that at n equal to minus 4 the same signal will repeat. So let me draw the same signal. So this is x of n minus 4 or n plus, which is equal to x of n plus 4. So this is 0, minus 1, minus 2, minus 3, minus 4, say 1, 2, 3 and so on. So it will be shifted towards left by 4 unit. It means at n equal to minus 4 the same signal will start. That is, this is 8, next we have 7, next we have 6, we have 5, 4, 3 and we have 2. So this is x of n plus 4. Now we'll try to draw x of minus n plus 4. So therefore Now let me draw x of minus n plus 4. So x of minus n plus 4 is reflection of this signal. So let me draw the reflection of this signal. So this is x of minus n plus 4. So these samples will appear on left side and left side samples will appear on right side. So at 0 we have 4, that will be as it is. So at 1 the minus 1 signal, that is 5, will appear. So this is 1, the magnitude is 1. At 2 minus 2, that is 6, will appear. This is at 2, 6. At 3 it is 7. At 3 it is 7. At 4 it is 8. At 4 it is 8. And at minus 1 this signal will come. Say at minus 1, this is 3. At minus 2 we have 2. So this is the y of n signal. We can see here this signal and that signal both are same. Similarly, now we'll take the second example, that is g of n is equal to x of minus 2n plus 3. So here g of n can be represented as, here we have to perform shifting operation as well as scaling operation. Here the first operation to be carried out is x of n plus 3. That is x of n plus 3 is nothing but x of n minus 3. It means that x of n signal is shifted towards left by 3 unit. Let me draw that signal first. After this operation we have to perform x of 2n plus 3, which is known as scaling operation. Then we have to perform reflection operation, that is it involves shifting, that is x of n plus 3. Then we have to perform time scaling, that is x of 2n plus 3. Then we have reflection, that is x of minus 2n plus 3. First let me consider x of n plus 3. So x of n plus 3 is same as this signal but begins at n equal to minus 3. This is minus 2, minus 1, 0, say 1, 2, 3, 4 and so on. So at minus 3 it is 8. Then we have 7, we have 6, we have 5, 4, 3 and it is 2. This is x of n plus 3. Now we'll perform x of 2n plus 3. So time scaling, x of 2n plus 3, let me draw here. X of 2n plus 3. As we know, in time scaling the signal will compress, that is at 0 we have 5, it will be appear as it is. Now at n equal to minus 1, this sample will, we have to discard this sample, it will lose this sample. Then at n equal to minus 2, that is minus 2 divided by 2, it will be minus 1. So the same signal will appear at n equal to minus 1. Its magnitude is 7. Say this is 7. Now again minus 3 divided by 2, it will be 1.5. That we have to ignore. We have to consider only integer numbers. So here onwards the value will be 0. Now on right side 1 divided by 2, it will be 0.5. That we have to ignore. It will lose this sample. Then at n equal to 2, 2 by 2 is 1. So at 1 this signal will appear, that is 3. And here onwards all the values will be 0. So this is x of 2n plus 3. Now we'll perform x of minus 2n plus 3. So x of minus 2n plus 3 is reflection of this. That is, let me draw here, x of minus 2n plus 3. Say this is 0, 1, this is minus 1. So at minus 1, this signal will appear here. That is 3. At 0 it will be same, that is 5. and at +1 -1 signal will appear, that is 7. So this is the G of n signal. Now we can compare this with this signal, both are same. This is how we can sketch the signals by using different operations. So here any method can be used. Thank you for watching.